up to this point you've been doing problems just with moles, and what we're going to do now is take that a step further and look at what happens in a more realistic situation when the problem doesn't give you moles but it gives you mass. Because in real life we don't have any little machines that are going to measure moles for us. They're always going to start with how many grams do you have. So I'm going to look at a problem that just came out of a book that tells me that we're going to have 1.72 grams of potassium bromide. 1.72 grams. So that's given in the problem. And the problem is asking me how much of this will be produced. So our first step then is to understand that I can't get there straight from grams. Because remember that grams are not a measurement of how many particles. And if I'm going to use a balanced chemical equation and use the ratios of the coefficients, those ratios are ratios of individual particles or groups of particles. But I have to be using something that measures particles, which would be moles. So the first step in any problem like this is to convert the grams into moles. Then I can use that ratio, which would be doing exactly what you've just been doing in the previous lesson. And then generally the problem asks us to express our answer in grams, which means going back to grams. So now we have to remember how to do all that stuff that we learned to do in the last unit. So let's begin and say we've got 1.72 grams of potassium bromide. So I need to convert that into moles. Now, one important thing to keep in mind when you're doing this is the molar mass does not have anything to do with the coefficient. When you're calculating molar mass, and you've done this a lot, you do not use the coefficient. The molar mass of potassium bromide is what it is, and it doesn't change based on what chemical reaction it is and what coefficient is next to it. So we just use the potassium and the bromide. If there are subscripts, then of course we use those, but you don't use coefficients for these calculations. I'm telling you how many students mess up their problems because of that, so don't do that. All right, potassium is 39.1 and bromine is 79.9. So 39.1 plus 79.9 gives us 119. So this stuff is 119 grams per mole. So this first step is going to take what we're given in grams and convert it into moles. So I can just look at this and say, okay, this is my moles. Now I remember what I was just doing yesterday. And remember that I can take the moles and multiply it by the ratio of coefficients. So the problem, remember, wanted to know about this. So there is 1 Br2 for every 2 kBr. So that's my mole ratio. So this is moles, and this is the mole ratio. And so once I do that operation, I'm going to figure out how many moles of this I can make. Now the question though asked me for how many grams I can make. So I'm going to do a third step, and I'm just going to roll it all into one equation here so that once we get the calculator out we can do the whole thing. And that is, I need to take that number of moles, convert it back into grams, and you remember how to do that. You multiply by the molar mass. Now it's a different molar mass than we used over here, because now I want the molar mass of bromine, which is up here. So bromine, we just said that that was 79.9, so multiply that by 2. Gives us 159.8. All right, so let's just review where we've been so far. This step converts to moles of the given. So that's what we do first. So in the problem, we're always given some amount of something, and that's what we had here. So I converted what I was given into moles. Now this is my mole ratio, so that converts to moles of call that needed. I need that because that's what I'm asked for in the problem. So now I've gone from grams of something that is given in the problem to moles of what I need. So one more step here. Converts to grams of needed. All right. So we'll use these terms. Given, that's what the problem gives you. Needed, that's what you need to find to answer the question. And we have 3 steps to get there. So let's go through the math here. 1.72 divided by 119. And then we'll divide that by 2 and then multiply by 159.8. Now, significant figures, I think 3 would be the max that I can keep here, so I have 1.15, and that will be grams of Br2, so that is the final answer there. Let me make one more note about that significant figure thing. You notice that I did not take these into account when I was thinking about significant figures. That's because those are exact numbers. This would really be 1.00000, a million zeros, and this would be 2.0000. So those, because they're exact numbers, they're not measured values that have been rounded off, then we don't have, there's no estimated place there. We don't have to even think about those when we do significant digits. So this is an example of what we call a mass problem.